Hello, everyone, and thank you so much for being here tonight. My name is Chris Whitney. I lead the team of industry experience for TripleTen. Very excited. This is my first co-jam that I have been able to participate with, so I'm very excited. Bear with me if I mess anything up, but I will absolutely do my best not to. Very excited to be hosting the co-jam today for November. And I'm glad that anybody that is watching or is here with us, I'm glad that you are here with us. It's been a fantastic time. And this is actually a very special Code Jam because we are uniting students from two TripleTen programs. We've got students both from data science and from software engineering. They worked in teams together to show us some amazing things today. So first, let me tell everybody who's watching what a code jam is. So if you're new to this, this is a very friendly competition for our students during their normal coursework. They are super short competitions where a group of our students get together and they jam out a bunch to code to meet the prompt. There are prizes, but mostly students like to compete for that thing that all developers want, a clean Jira board. That's laughter, laughter, laughter. Haha. Just kidding. It's really the sense of pride to be able to win and to compete and to work with some of their fellow students. So this code jam consists of three parts. There's the data part, the coding part, and then a presentation. So last week, our participants were divided into teams of five, two DS students and three SE students. And they were challenged to collaboratively turn spending data into simple, helpful tools for the shopping season and to create a helpful shopping apps. And here's the interesting thing is that they only had 6 days to do it. And the prompts were smart budget planner or a spending personality test. So today the teams are going to show their projects off to all of you that are watching, and then our judges will review them next week. The judges will be evaluating all of the data, the code, and the presentation, and the results will be presented on TripleTen's Hub by November 21st. All of our students and those who watch us here can vote for their favorite project during the following week, and the winners of our Audience Award will receive special prizes from TripleTen. So please make sure to leave your comments below on which project was your favorite. So it's time to jump into our presentations. I'm very excited to see everything that we have accomplished, and I just want to collectively wish everybody the best of luck. So we have three teams today, and we are very excited that they could be here with us. The first team is the Smart Spenders. With us tonight, we have Gio Faldu, Raphael Liu, Vinod Anthony Jacob, who will be presenting for the Smart Spenders. We also have the second team, which is the Budget Balancers. We have John Fu, Brittany Mancado, and Cassandra Peterson. And the third team we have that will present tonight is Team Wallet Vibes. We have Ahmed Taib. Excellent. I love the enthusiasm. We have Christopher Rivera, Sophia Villazon, Lala Blue, and Michael Borges. I do apologize if I mispronounced anybody's names. Please correct me, and I will try not to do it again. So to start us off, we have the Smart Spenders. So those who are presenting, feel free to share screen, and let's see your presentation.
Let me share my screen then. Once can't. Oh, they moved all the buttons. See, is Jill on? Oh, there we go. Can everyone see my screen now? Perfect. So we are the smart budget planners or the smart spenders, and we decided to go forward with the smart budget planner project. So I am Raphael Liu. I'm one of the TripleTen data science students. One of my coworkers for this project on the data science side is Jill Faldu. And then we have our software engineering team. We have Alfonso, Giselle, and Vinod with us today. So the goal of our project was to first clean and aggregate the data that was given to us and compile them by customer, by spending data, and consolidating them to a JSON file for delivery to our software engineering team. And from there, the software engineering team created a minimal viable product for us to display to you guys today. So we'll get started with that. So the data set that we used, we sourced from Kaggle. It was actually a synthetically created data set originally used to train for fraud detection software, but we also able to leverage that into a budgeting platform. So this data set included over 7 million transactions from just under 5,000 users. It contained transactions from 12 different countries in 12 different currencies, and it spanned the period of October 2024. Within this data set, we were able to find 8 different merchant categories and with 17 different subcategories. And this data set also included whether or not a transaction was made in a particular user's home country. So there were more features this data set included, but these were the 6 features we decided to focus on. So we first grouped all of the transactions in the data set by the customer ID number. And then we are able to find out whether or not, so based on the feature called distance from home, we were able to determine whether or not a transaction was either made from abroad, made from the customer physically being abroad, made from their home in a foreign country, or if they were a multinational, which they had assigned themselves different countries as their home base. However, for the purpose of this this project, we assigned a home country to these customers based on the country which they had the most frequent transactions. From there on, the transactions that these customers made were converted into their home currency using United States dollars as of November 2024 to convert to their home currency value. And customers were then grouped into individual data sets by their home country. So what was interesting about this data set was when we first ran the numbers, we noticed some potential errors in it. When we used, according to the documentation of the original data set, distance from home indicated whether or not a specific purchase was made from abroad. Distance from home 0 meaning at home, 1 meaning abroad. However, when we actually did run those numbers, it gave us a very strange distribution showing that the supposed 382 US-based customers, and we decided to focus on the US sub-data set for this analysis, that the mean spending for these customers just within the month of October was $500,000. And unless we were suddenly dealing with a data set of multimillionaires, we found this to be an anomaly. In a real world situation, we would interrogate this further with the original source of the data. But for this project, we just assumed that there was an error in coding where distance from home equals 1 is actually our original US-based customers. And you can see here's a visual of how the data distribution changes when we made this step. Where on the left, you can see customers' spending habits if we had assumed that the original data set was true, you would see customers spending anywhere from $200,000 to $600,000 a month, which is not reasonable. Whereas once we fixed the coding error, you were able to see that we have a much more reasonable distribution of customer spending with a positively skewed data set. So let's see, is tool on? So let me proceed with this then. So after we went through all the data, we were able to create different displays of spending habits across customers and across categories. Here's a view of one of the customers that we've selected. You can see here that for this customer, their highest spending category was travel at 1.5 times the average. And they're with gas spending a little bit above average, and then other categories either at or below average. And this is a further breakdown of their spending. So you can see again on the right side that for this particular customer, they probably traveled in the month of October, and they were travel was a majority of their spending. And here is another view of a customer where we see that for this particular customer, they didn't have any specific spending category where they exceeded the country's average spending. So further improvements that we could make. So while we were able to deliver all of the country aggregate data and the different charts to the software engineering side, we weren't able to deliver a model that we developed in time. However, for future iterations of our software, what we can do is we can create a neural network using the data by country. I'm building a tensor of 31 by 19. Each of the individual rows represents a specific day in a specific customer spending, and to predict on the total amount of spending by the end of the month, and using masking so that we can provide a customer estimate of how much they'll be spending in total on the 5th, 10th, using data from the 5th, 10th, and 15th of the month. So yeah, and the neural network that we proposed would use LSTM, which is long short-term memory. And this is a preferable neural network architecture because it leverages the ability to handle sequential data because the algorithm remembers specific trends across time. And as of 5 minutes ago, I was still training this model. We were able to get it down using mean squared error as a loss. We were and then taking the square that we were able to get around a loss within 3,700 of end of month prediction. While this is still not ready for implementation because many customers won't even spend more than $3,700 a month. This is with further tuning of this model, we could deliver to our customers to, at various points of the month, predict how much they'll be spending from month to month. So now I'm going to hand this off to our software engineering side.
Good evening. My name is Vinod Jacob, and here's the application we built based on that data set. This is the Smart Budget Planner. We obviously have the dashboard, which is showing the user summary, the income, location, and currency, and the insights, and then obviously the spending breakdown by category. And then you can update the income that you're using, and it will calculate the expenses for the month. And the dashboard auto detects the user's country and tells them and automatically gives them the right currency that they are looking for. Instead of exposing the public list of user IDs, we're using manual user ID entry, which will be a future implementation. And that's the dashboard, and then you have the expenses module, which allows you to enter in different expenses and select which date you'd send it, and if you had an optional description, you can enter that, and it will show the restaurant grouping by the category, how many expenditures there is, and the date that was done on. And this is the budgets feature, which is set the track and budget for each category. And then we have a reports tab, which allows you to visual analytics, which are future implementations, obviously they're based on the time constraints. And that's about it.
Excellent, thank you. I noticed there were a couple of other teammates on the call. Did anyone else want to add anything? Terrific. I appreciate the presentation. Thank you so much for sharing that. All right, let's move to the budget balancers. Who's going to present first?
Hey, I think John, our project manager, was going to present on his end. We were going to support him as he went through the slides. John, do you want to pull it up?
Hi everyone. I'm going to share my screen real quick. All right. Can everybody see this? What's on the screen there? All right. All right. Our project was called, we decided to name it affectionately Budget Blocks. It's a smart personal budgeting app. We designed it together to something that we'd personally would like to use in the amount of time allotted. Oops. Okay, our team members are mostly here. We're just missing one today. We have Nat, Brittany, Cassandra on the software engineering side, and myself and Victor on the data science side. So Brittany's going to talk about what they did, and Cassandra will give you a little taste of the application itself when she's done.
Okay, go ahead to the next slide. So some of the challenges that we faced early on with this code jam was, for one, each student engineer was in a different stage of their learning journey. There was no two engineers that had the same level of skill that we could have combined forces. The next layer of difficulty that we had was our availability, because each engineer was in a different time zone. So even that added more complexity, on top of the fact that two engineers are moms. So that, kind of added a little bit more restrictions, differing experiences. And in addition, for me, like, for example, this was my first code jam. But then for Cassandra, even though this is her first code jam, this was her first time leading as a on the software engineering side. And then retrieval issues that we had as well. So for instance, I haven't started React yet, so I don't have all of those programs installed. So once I finished doing some front end stuff with HTML and CSS and JavaScript, and then Cassandra started collabing on, and then some of her programs got added in. Whenever I wanted to kind of retrieve the data that she added, because I lack those programs already installed that she had, I had no access to it. So that added some complexity, but we worked around that. Go ahead, John, you could go to the next slide. So this is how we ended up kind of dividing out our time. I'd say about, 19% we spent collaborating, brainstorming, trying to figure out what is the most realistic approach that we should take to this with all of our restrictions considered. And at the end, what we ended up doing was kind of building off of each other. So me, I would think of me as like the baby engineer because I was the one with the least amount of sprints completed. And I was able to at least confidently do the front end for the HTML, CSS, and some JavaScripts to get the forms for a login form for users to log in, the sign up form, and then just basic open and closing functionality to the modals. And then I kind of passed the baton to Nat, who then added in the React and added in some cool features where it was actually able to store the user's data and actually retrieve that data and authenticate the user to be able to log in to the app after they've registered. And then Cassandra, I described as the backend glue, where she kind of tied everything together, was bringing the front end files and then the back end files and connected it all together for us to be able to see everything hooked up. Okay, so now some of the features that we included were forms. As I already mentioned, the login and the sign up forms. We also have an expense tracker, which, you could add in. We divided it out per category: transportation expenses, fun expenses, home expenses, basic expenses that one has. And as the user adds in different expenses, the tracker kind of automatically adds everything together. The responsive results was the part that was able to compare our users' data that they manually entered to the backend data that the data engineers gave us to kind of compare and contrast, say whether they were doing more, or spending less, right on track, and so forth. And then the automation feedback on financial data. And that's the part that actually provides the user the feedback. So the responsive results does like the math in the background, and then the automation kind of brings up the alert to the user itself. Thank you, John.
All right, great. And Cassandra, can you please, I'm going to stop sharing for a second. You can share your screen and show them our working MVP.
Okay, is everyone able to see? Okay, so did you want me to show this part first, John?
Yep.
The actual app? Okay. So we've got a login and then also a sign up form. And we also have it to where it saves a token so you don't have to always manually type in your email and password. And we have down here our expenses when we add an expense. And we can choose a category and the date. And you can also delete them. It will send an alert, but it will also update up here and it will compare the data to the national average. And I was able to put in a slider here as well as some alerts to let them know if they're overspending or kind of where they're setting. And I used that, or I did that by using components. And then I routed them into the dashboard. I think that's about it, right?
Yeah.
Yeah,
Yeah.
John,
Can you?
move on to the...
Yeah. Can you go ahead?
I'm sorry.
All right. No, that's fine. Thank you very much. can stop sharing and I'll go ahead and continue.
Yeah.
Okay. All right. So I'm John. Me and Victor, my partner, we were on the data science side. And we were struggling with this challenge because the data set kind of looked wonky, and I think the other team alluded to this as well. Instead of giving you like a technical textbook lesson, I'm just gonna start breaking it down. What we saw like initially. First of all, the data set was extremely large. It was something bigger than we normally do. That's not that big of a deal, but as we dug into the documentation, it mentioned that this data set was synthetically generated. The data set was originally built for fraud detection, and the data set was heavily skewed, and it didn't seem like it was in line with real world spending. And we'll see a little bit more of that as we continue on. Just by the numbers, real quick, looking at this data set, had about 7.4 million total transactions, 2-month window only. So it might be a little bit difficult for predicting monthly spending cycles. The data set size was kind of large, 2.8 gigabytes of only just the CSV file. And they had 8 user categories that were piped into our working MVP. So just to give you an idea, if you look at September spending on average, this is even after we cleaned it up a little, like education, the average education spending per person was 53,000. Gas is at 53,000. Oh, and this is after we converted everything into US dollars. These numbers are like Amex Black Card numbers, right? Like no real person spending this in a month. And so we were struggling with the real world applications of a data set like this. If you have numbers like this to spend, you're not using a budgeting app. You don't care, right? You got probably like oil money and you're just spending whatever. Secondly, it was really hard to tell like how accurate the numbers are if they're at ludicrous amounts like this. So we had to go back to the drawing board and take a look at what was going on, and try to come up. So a lot of the things that we did to try to like get these numbers into more in line with like realistic spending numbers. First of all, we excluded all the values that were frauds, that were clearly marked as fraudulent transactions, converted everything to USD. We excluded all the outliers, and we removed extreme transactions to get this more in line with what would happen in reality, in order to have like a functioning budgeting app that we could have, like say a young adult who just came out of college, like it would mean something to them. Like I don't want to like already skew their warped perception of the world as it is. And in the cleaned data set here, uh, Victor can talk more about this.
Okay. Hey everyone. So I'll explain the spending distribution across 8 merchant categories. So this slide shows the travel with the highest average spending and restaurants the lowest. And all of them are visualized in the graph chart. The next slide. So here we are analyzing a sample user who spends 94% more than the median user at 13,000 monthly, with restaurant, entertainment, and the travel in the top of from 10 to 25% of all users. And the categories shows that there is no unrealistic numbers. And your slide.
Okay. And so we also found a few interesting things in our insights. One of the things that did make a lot of sense was that when we looked at the spending and where the spending occurred, on average, the it looked like the average transactions were about 10% more or slightly under 10%, which kind of aligns along in like the real world. Large cities tend to cost a little bit more for everything across the board. So that was one thing that kept grounded in reality in the data set. Sorry, went too far. Go ahead.
Okay, so this pie chart visualizes the user spending distribution, showing the travel 23.9% and the retail 15.5% as the largest budget portions, and followed by the restaurant 12.6% and the entertainment 11.3%. Next slide.
Thank you.
So here you can see the z-score analysis showing a sample z-score of 0.11% and indicating a near average spending across all of these 8 categories from 7.4 billion transactions with an average of standard of $42. Next slide. And on my last slide, the information, what is the project has achieved so far, and the advanced analytical features that we are planning to add the next time.
Okay. As this project was limited in scope and time, we really wanted to focus getting the data to a usable state for a budgeting app. If time permitted more, we discussed several advanced modeling things, similar to the other team. I started going off on a tangent about like actually performing the fraudulent modeling project just to see if we could remove all the ones that we marked as frauds and see if it would bring the numbers more in line, but it didn't seem like it would. And so we just tried to contain everything into something to be a usable product for the real world. Okay. And yeah, thank you for coming to our presentation. Our team was building team build blocks, and we're looking for seed round funding for $1 million USD if anybody's interested.
Fantastic. We definitely have earned it. I hope you find that angel investor tonight. Fantastic.
Thank you.
Thank you so much to the budget balancers. I appreciate your presentation. Let's move
I
to-
also wanted to add, sorry, I'm nervous, so I kind of went through mine really fast, but I just did want to add that we do have it connected to the Mongo database, and I have it set to where it hashes out the password before it gets to the database, so there's no text or HTML in there. And then also, it was my first time having like data set and putting it into, you know, like the software engineering side. So it was fun to make that config file and then, you know, make the functionality file and then create components and route it into the whole app itself. So just wanted to add a few more things that we had also did on the project.
Absolutely. Thank you. And thank you for even putting it out there that you were nervous. Totally fine. Me too. This is my first Code Jam. I'm here with you. Thank you so
Okay,
much.
cool.
Thank you. Thank you. All right, let's move on to the third presentation. And then I do have questions for everyone after we finish up. So I hope that's okay with everyone. But we'll move on first to Team Wallet Vibes.
Yeah, let me share my screen. I think this is the whole point of having this competition, to learn and, you know, go over all these feelings. That's so good to have everyone. Okay, hello everyone. Actually, we're Team Wallet Vibes. Together, Chris and myself, Ahmed from Data Science, and Mike, Sophia, and Lola from Software Team will unveil valuable information further. We're going to present the Spending Personality Test project, a project where we take real consumer spending data and turn it to meaningful financial personality types. It's so, you know, it's to understand how people shop, how they use deals, how much they spend, and whether they plan ahead or buy impulsively. This project actually bridges data science and software engineering where we analyze behavior and build personality logic on the DS side. And SE team uses our rules to create a quiz-based MVP for users. So our goals as a DS team were simple: clean and explore the dataset, engineer meaningful behavioral features, and use K-means to uncover natural spending personality groups. We then convert those insights into a JSON file that the software team can plug directly into their quiz MVP. So EDA, we use a Kaggle dataset of over 2,200 customers, clean inconsistent categories data like YOLO and observed, and handle the missing income values. We then engineer behavioral feature like spending patterns, deal usage, and purchase channels, which are essential for identifying spending personally. In this slide, this distribution shows the income and total spending are right skewed, while age is more normally centered around 40 to 70. Most customers spend $10 to $50 per purchase and make about 5 to 25 purchases, which help us identify whether they are frequent or high value shoppers. Kids and education also checked, and those have more those have only minor influence on spending. Education mainly matters because it's correlated with higher income. So the key relations show that higher income leads to higher spending, while heavy deal users tend to spend less. This pattern helps us choose the most meaningful feature for clustering. The correlation matrix reinforces our findings. Total purchases strongly correlate with total spending. Deal heavily behavior correlates negatively, and channel preference show clear behavioral differences. And using the clustering inside, we build a simple rules engine where each personality has a clear conditions, a behavioral description, a cluster mapping, and 3 saving tips. However, we use K-mean clustering to finalize the JSON that Chris will take. We'll talk about that in the next slide. Go ahead, please, Nick.
Thank you, Hamid. So in order to prepare our data set, we split the data into features X and our true labels personality type to determine how the K-means algorithm can cluster the data relative to our rule-based system. Our features consisted of most of the original features to see if the algorithm can capture any nuances our rule-based missed. Our target was used to analyze the clusters and compare with our true labels. On the next slide, you'll see our approach. We use the elbow method to determine the ideal number of clusters for coherent grouping. The problem we faced is the results showed that for the algorithm to perform ideally, it would require way more than 8 clusters to reach an acceptable inertia score, even after reducing the features down to 3 principal components. The solution was we iterated through a range of components and found that 10 principal components captured the minimum acceptable variance explained of 70% without overloading the K-means model with too much noise. In the next slide, our results were that the 3 principal components did not capture enough variance within the data set, so we moved on to the 10. And the model was able to cluster the data into 4 groups. So we tested these groupings against our rule-based groupings. And the metrics we used was adjusted rate random scoring, normalized mutual info score, and V-measure. They all scored very low. On the next slide, we'll explain why. So the spending behavior contains clear, quantifiable personality types. K-means clustering and PCA was not able to validate our rule-based approach as it would require way too many clusters to capture the full context of the data. The final JSON logic is simple, interpretable, and production ready for the software engineering team. This project demonstrates how data science and software engineers collaborate end to end from raw data to a user-facing personality tool. On the next slide, we go over the limitations and future improvements. We came across many missing values. Personality labels were derived from strictly from a rule-based classification, as Hamed described. Spending behavior is influenced by external factors. The clustering algorithms don't always do well objectively grouping large customer bases down to a small number of clusters. Limited time to fully uncover the nuances the algorithm picked up and necessary adjustments to the rule-based engine. Future improvements include more behavioral signals like browsing activity, time of purchase, and product category, maybe including customer surveys to create true label data, and including data with other types of purchases like clothing, investments, books, etc. And now we'll pass it over to the software engineering team so they can give you a demonstration of our MVP.
All right, hey there, guys. Just trying to get this this up. Ready? Should be sharing now. Perfect. All right, guys. Thank you for joining us. So here, let me try to close this as well. Alrighty. So again, we made our spending personality test. As Chris was mentioning, one of the bugs that we had to deal with was the clash between the DS and the SE kids. Him and Hamed were absolutely perfect with gathering this data as well as getting it together. But when we showed them what we had and what we were making, having them reformat the data so we could put it into a functional array that rotates through our questions, our answers, and as well as including the values to really show, which personality you'll be receiving based off of if you're a saver, splurger, and so on. We really tried to showcase our HTML and our vanilla here, CSS, JavaScript, since not everyone has been so far in the program. But it was perfect, give us plenty of time to truly work on what we're doing. We included different hover states as well to make sure that the users were able to identify what is clickable, what's not. We read in depth on refactoring UI to try to give 3D layouts to our question text frames, as well as our buttons. We also added validation states to make sure no one can just skip through this thing and have a bunch of different errors or not really receive the answers that they want to. As you can see, we also added text frames, allowing color changes to really impress the users with a nice, clean, elegant design in the UI to really indicate which answers they're selecting here. And as we make our way to the final page, you'll see that we have a nice little jump to what they might receive. So if you were to select all those, we have our description showing the image and things, so on. We also wanted to make sure that, not everybody likes to use a computer or a desktop. So we wanted to not just include one, but we wanted to include 3 total overall designs for media queries. That way, if you're on a tablet or, for instance, a phone, you were able to still have a great user experience while clicking through your cards and making your answers. Sophia, she did an amazing job connecting all of this JavaScript, taking in the data from the DS kids, and really showcasing her skills as not only a software student, but as a great software engineer. All of us really worked really well together. And I mean, overall, this was just a very pleasant and, genuine experience. Sorry, I got impulse by her again, but I guess that just might be me. Other than that, that's our project. And I really hope you guys had a great day.
Absolutely fantastic. Thank you so much for all of these presentations. I really enjoyed them. If I could ask the groups a couple of questions, I'm really curious to hear your feedback. So let's jump first to the smart spenders. So you were the first ones to present and you started talking about the data. I would love you to kind of elaborate a little bit on, Raphael, what you saw of the challenges with using curated versus real data.
Sure. So I think the other team also noticed it as well. The numbers at first were coming up really funky. So what I had to do was I went in through every single variable, started filtering group by different aggregations, and I found out that when you switch distance from home, the logic from 0 to 1 went to 0. You get an actually anticipated distribution range. And of course, like I said, in a real world scenario, you would interrogate with the data procurement team about the data. But it was nice to use a large data set because we're able to like play around with it, which is what you would typically expect in like when you're actually trying to build out a software.
Yeah, definitely. I'm kind of working with outliers and kind of making some assumptions there. Absolutely. So other members of the Smart Spenders, talk about the collaboration a little bit. I'm certain that this is the first time for some of you that you've had an opportunity to collaborate inside of TripleTen, but inside of a DS or an SE work environment. What was that collaboration like?
I mean, I think it went very well. We just obviously it was obviously the time constraint was a bit there, obviously, and on top of that, we have our core regular coursework that we still have to do, and obviously daily life. So it was just obviously it was a difficulty in trying to get schedules aligned, and then in terms of that, and then obviously once we started working together, chat, and we found our good messaging medium that we could chat over and that sort of thing. And on top of that, I mean, this is my first time doing this code jam, so it's and obviously I'm only just started at the sprints. I'm not at the level of all this data and modeling and all that stuff. So it was just something. It was exciting to learn, and I tried to contribute the best I could, and that's. I mean, I give props to the other members. They did most of I helped as much as I could. So.
Fantastic. Now, I'll stay right with you for a second, so maybe you can talk about that. One of the other teams talked about the challenges of students being at different stages of the learning. So maybe you can start, and maybe another one of your team members can talk a little bit more about those challenges and how you mitigated that.
I would say I mean, obviously the main challenge for me was that I didn't know most of the terms and how to get this data into there. I only know the HTML side of things and the CSS. I didn't, and I'm just starting JavaScript now, so I kind of little understand it. I mean, I know it from a previous life, but it's not as much as this level of what TripleTen is teaching it. So, um, that's my challenge. And then my other two teammates on the software engineering side, just they know more about JavaScript and all the other data points, and they basically did most of that legwork, and then I just helped with the HTML.
Perfect. Any other smart spenders have some insight to how you mitigated the challenge of having learners at different stages?
I actually don't think the rest of our team was able to make it tonight.
Okay. Well, but I think Vinod, you definitely described that well. So thank you so much. So let's move on to the budget balancers. And I wanted to, you were one team that definitely talked about those challenges at being at the different stages of learning. But Brittany, I wanted to give you some kudos because one of the things that's so, you called yourself the baby engineer, but one of the things that is so important that you did so well is the ability to describe the work that you're doing to people who are not a part of the work. So somebody like me, who is not an engineer, who is not in the curriculum that you're in, but I could understand very well how you kind of walked me through the process of what you were doing. So I wanted to say kudos to that. I think it was amazing. The other thing I wanted to talk about your comparative to the national averages and how you kind of came about that and why you thought that that was important to do. So maybe a member of your team talk a little bit about the national average comparatives.
I'll let Cassandra take that because her and Nat worked on that part together, but Nat's not here. So I'll let her talk a little bit more about that.
Please.
Yeah, so I created a config file, and that's where I put the data from the data science students. And then I created the benchmark JavaScript where I created a function for the or is outlier, and then a function for the get overspending categories, and then if it's outlier, and then also the get monthly benchmark and to get them by the categories, and then to compare it to the national average, and also to get the comparison message. So that's what creates all of the alerts. Like if you're spending good, then woohoo. And then if you're not, then hey, we're going to alert you. We're going to let you know. And then I created a function for the get status color. So that's what will show if you're doing good, then it's going to show a green status bar. But if you're not doing good, it's going to show red.
Perfect.
And then I exported that. Yep. And then I just used it throughout the app and was able to glue it all together, as Brittany says.
Yes, absolutely. You know, I think one thing that you explained well as a team is kind of those differences and the challenges that you had. So how did you, as you started out, and you only had 6 days to work together, how did you start identifying some of those challenges early on and that would help you to work on them together? What did you do as a team?
Well, I think the best thing that really just kind of launched our kind of analysis of how are we going to work together was John just kind of asking us from the jump, okay, what is the bare minimum that everybody can do? And then from there, we were able kind of to collect like, okay, at minimum, Brittany can do this. Okay, well, at minimum, Nat can do this. And at minimum, Cassandra can do that. So we didn't, from the jump, we did not have a timeline for the whole 6 days. We kind of took it by milestones. So we were like, okay, let's first try to, at minimum, complete phase 1. And then once we completed phase 1, it's like, okay, cool. Sometimes we would reach phases where we did more than what we was anticipated. Like maybe I added in a little bit more than what was assigned to me. Same thing with Cassandra. Like when it got to her side, she would add in a little bit more than what our minimum was. And then by like day 3, we started realizing like, okay, cool. We got most of the minimum. Let's try to add in a little bit of flair. Let's try to add in the pie charts now. Let's try to, so we kind of like went with the flow of things. Like we could have maybe in retrospect, we could have had a stronger timeline from the jump. Like, okay, by day 1, we want to do this. By day 3, we want to do this. And then by 5, we want to have this. But we kind of broke it up. And even with those small milestones, it was able to still help gauge us with what we had as far as time constrictions went.
Yeah. Well, watch out. You're working inside of the agile method right there. So fantastic. I mean, that's what it's all about. It's about, identifying those milestones and as you're learning and building and what can you do? What can you accomplish? What can you accomplish more? So you're flexing there a little bit. Good job. Good job. All right, let's move on to Team Wallet Vibes. Very cool. I'm wondering if you can just talk to me a little bit about what the elbow method was that you chose to use for the data.
For
Just
sure,
real quick.
that's a really good question. So, um, the elbow method is a way to determine how many groups this algorithm can properly cluster the data set. So the lower the if Hamed, would you be able to pull up the chart so we can kind of put a visual to my explanation?
Just bear with me, okay?
Thank you, brother.
I just closed everything.
Of course.
Just give me a second. Are you able to see this? Yes.
Yes.
Okay. I think you want to talk about this slide.
Yes. Okay, so as you can see, the numbers on the bottom, it's the number of clusters. And the label, the vertical label, it shows the what the inertial score is with each number of clusters. And so ideally, we want these numbers to be zero. So the inertia score measures the accumulative distance from each point within the cluster from its center. So can you go one slide up for me, please? Or I'm sorry, down I meant. Yeah. So on the 3D visual on the right, I have the centers of each cluster marked with an X. So if you notice, you'll see a lot of dispersion. They're very sparse clusters here. And so the sparser the clusters, the higher the inertia score. So ideally, we would want these clusters to be more dense. And if it's more dense, then these groups or these custom each dot is a customer. So you want those customers closest to the center. So therefore, okay, this customer belongs here.
Mm.
Whereas if you have all these dots like looking like outliers or straying away from the center, it could be possible that they in all actuality belong in a different group. Does that make sense?
Yeah, absolutely. Thank you so much for explaining that and talking about why you would want to use that method to kind of look and to create how many clusters you needed. Thank you. I
Yes.
appreciate that.
No
Another
problem.
thing that I wanted to ask this group is, so after the pass off of the data, so what does the collab look like after that? I know you were in a 6-day model, but maybe even if you kind of project in the world of work, but what does that collaboration look like after the pass off of the data?
Yeah, absolutely. One of the and before I actually answer that, I forgot to totally mention Lala, and I fully apologize to that. She was absolutely instrumental to our project as well. So I want to apologize to her. I wanted to make sure we stayed within our 10-minute time frame. So, but our collaboration, we actually from the day that we met from the brief, we worked together every single day. We had made sure we had scheduled meetings, across time zones, especially with me flying out to the East Coast to see my mom and working through, the week. We really made an effort to find time with all of us together. When the data first came in, it was a little hard for us to understand because we typically don't work with data. However, the way that Chris and Hamed were able to take the critical feedback of, hey, this is what we have, this is what we want to do with it. They really understood like, oh, okay, this is the mission we now have on hand, and they completely restructured what they had to format in a way that we were able to pull things, I mean, extremely easily into our design to keep it clean, elegant, and efficient for the users. When we were first given the brief, you know, we all kind of thought about what is fun and what makes us happy. And, you know, a lot of us were like, yo, there's BuzzFeed tests and the Harry Potter house, which one are you? And so we really want to work together to, you know, just make something fun for everybody to just kind of play around and click a bunch. So.
Fantastic. Thank you so much. As we wrap up, is there any final thoughts about the collaboration, about the work, about the experience? I'd love to give you the floor.
When's the next one? Because this was absolutely amazing.
Fantastic. Fantastic. I love to hear that.
I think my team really benefited from my professional experience, and perhaps it's something that previous to this I was a project manager and project manager, program manager, whatever you want to call them. And so organizing what we could do in the meaningful amount of time that we had was kind of hard, and I can see that other teams may struggle, or in the future, other teams may struggle with this. But maybe we can add a TripleTen program for like agile practitioner or whatever, because they're needed in the tech field as well, and that would really benefit the teams a lot.
I could not punctuate that enough, John, I think. But one thing I find really interesting with all of the folks that I've had the pleasure to interact with at TripleTen is that we all bring something very different to the table. We all bring different life experiences and career experiences that I hope that we bring to these collaborations. And when you have the next opportunity, even an externship, that you bring your past life into this life and use all of those skills. So thank you so much for saying that and encouraging everyone to bring who they are, their authentic self, all pieces of you to the experience, because I think it's going to make it very, very robust for all of us. But thank you so much, everyone, for your time and your energy and your presentation. That's all from us here at TripleTen for the November DS and SE Collaboration Code Jam presentation. Thank you so much for watching us. All students and viewers, please make sure to comment so you can cast your vote for your favorite project. The results and the winners will be announced by November 21st on TripleTen's Hub. I'd like to send out some special thanks to everyone who helped organize this Code Jam. Devin, Josh, Daniel, Marcella, Natasha, Liana, Anastasia, Denise, and of course myself. But thank you so much for everyone for presenting your work today. We are so impressed by what you've been able to build and all of the things that you've learned and shared with us tonight. Thank you for being so brave and enthusiastic. Again, my name is Chris Whitney. Everyone can find me on LinkedIn. And until next time, thanks so much for watching. Have a wonderful evening.